we're going to do this again. I just recorded it and I can't find it. So, let's talk about bonding. Now, this is, I'm changing things up this year. This is 2020 when this is being recorded. And it is actually really apropos that we're doing this right after we redid the double replacement lab, because the double replacement lab is all ionic compounds. Now we're going to start talking about covalent compounds. We know the rules for naming covalent compounds, and we've actually looked at covalent non-compounds versus ionic compounds in a lab back in November. All right, covalent bonds are when electrons are shared between two atoms. They're created by trying to achieve an octet of 8 electrons around each atom. Each bond consists of 2 electrons, and compounds are always electrically neutral, which means they do not carry a charge. If you have a covalent group of atoms that have a charge, those are polyatomic ions. And we will talk about those. 2 types of bonds. The first type are ionic bonds. We know that those electrons transfer from one atom to another because they're composed of cations, also called metals, and anions, which are either nonmetals or polyatomic ions. Covalent compounds, the electrons are shared, and they consist of 2 nonmetals. Now let's talk about what this means with electronegativity. Electronegativity is attractiveness. If I have a metal and a nonmetal that are together, the metal has a very low electronegativity. The nonmetal has a high electronegativity. And consequently, that electron, if this is my cation with a low electronegativity, and my anion with a high electronegativity, that electron is attracted to the anion, and it actually jumps ship and goes to the other atom. So you end up with a positive charge and a negative charge. Covalent compounds, however, you're working with both compounds that have relatively high electronegativity. So nobody's going to win the battle over the electrons. That's why they're shared. However, they don't always share equally. A polar covalent compound does not share equally. A nonpolar covalent compound shares electrons equally. How do you tell whether it's polar or nonpolar? Well, you actually need to know about ionic too. Oh, this word is electronegative. Electronegativity. You actually have to look at the electronegativities. Okay? For instance, if we start with sodium and compare it to chlorine, sodium has an electronegativity of 0.9. Chlorine has an electronegativity of 3.2. I want to know the difference, so I'm going to subtract them, and I get a difference of 2.3. Okay? That is between 2.1 and 3.3 here, so that would be an ionic bond. If we're talking about 2 bonds that have very similar electronegativities, for instance, if we have oxygen bonded to another oxygen, oxygen is double bonded, oxygen's electronegativity is 3.4. If we subtract 3.4 from 3.4, we end up with 0. That would be a nonpolar bond. That's the other extreme from ionic. Similarly, hydrogen and carbon. Hydrogen is a 2.1. Carbon is a 2.6. I almost said 2.4. If I subtract those, and hydrogen's 2.2, I can't even remember. If I subtract 2.6 minus 2.2, I end up with a 0.4 electronegativity difference, which fits into that category. So both of these are going to be considered fairly even sharing. What's not even sharing? Well, the best example is hydrogen and oxygen. Hydrogen, again, 2.2. Oxygen, again, 3.4. The difference between those two is 1.2, which fits in between our range of 0.5 to 2.1. Okay, so if we draw a hydrogen-oxygen bond, what that means is the oxygen, who has 6 electrons, and the hydrogen has 1 electron, the oxygen is going to have control of those electrons more. It's going to spend more time over here. So he ends up getting a partial charge, and the hydrogen has a partial positive charge. And this is why water acts the way it does. All right, if you were in class, I'd have you get out your notes from the lab that we did in November on ionic and covalent compounds, but you aren't. So hopefully you'll remember, having done this, that ionic compounds all did not melt, meaning that they have low melting points. Covalent compounds did melt. They have high melting. I lied. I did that backwards. Ionic has high melting points. Covalent has low melting points. I would try to edit it, but I'm doing this on the iPad, and I'm not very good at it. Editing, at least. Conductivity. Ionic compounds will conduct if they're aqueous. And we did that. We put them in water. We put the little conductor things, my homemade conductor things that had the little LED light on them. Covalent compounds will not. Which reminds me to tell you a joke about a conductor, if you really want to hear it. Solubility. If you have water, ionic compounds are soluble in water. Even we've been looking at black and white, kind of soluble or not, but everything has a certain degree of solubility. So even the ones that we know the solubility table says don't dissolve, they'll dissolve enough that they'll conduct electricity. So ionic compounds are soluble in water. Covalent compounds may be soluble. In a solution, ionic compounds dissociate, which means they've broken apart. I'm using quotes around broken apart. Whereas compounds that are covalent will not dissociate, but instead dissolve. You can see the water molecules here. Can you kind of see in the middle? In the middle of this, you can see some black. Those black molecules or atoms are carbons. This is supposed to be a sugar molecule right here. And that sugar molecule is made of carbon, hydrogen, and oxygen. So it kind of looks like we've got water stuck to it, but really that's a molecule of carbon, hydrogen, and oxygen. I have a sample that I've held up before that's in a ring of glucose. You can see that surrounding this we have water molecules. If there's an attraction between the polar compound and the water molecule, it will dissolve. So dissolving is different from dissociation. Here in the dissociation, our negative ion is surrounded by water molecules. Our positive ion is surrounded by molecules, but they're not together anymore. They dissociated. All right. So in solution, covalent compounds, we say they dissolve if they're polar and it's a water solution. If it's not polar, and we aren't going to worry too much about polarity right now. We'll come back to that later, and I'm not going to worry about that blank. All right, the next part has already been done. It's the video, so you can watch that video as well, and we'll move on from there.